Good my dear student. So in this class also I'm going to solving some numerical to find the natural frequency of by using different method. So last class we studied about the how to find the natural frequency of a simple pendulum. So again the continuation of that. So again we are going to take the another three systems. We are going to find the natural frequency of the particular the given system. So this will come under module 4, that is a free vibration chapter. So this is about the part second of that module number 4. So part A is nothing but the basic concept of, that is introduction to vibration. Second part is the undamped free vibration, that is to find the natural frequency of the particular given system. So here they are asking what, determine the natural frequency of a compound pendulum. They may ask you in the examination around so 8 to 10 mark question. So they may ask you, they will not mention any the given what diagram, that is what given data, nothing they will mention. So they may ask you directly determine the natural frequency of the compound pendulum. So before solving this we have to know the what do you mean by compound compound pendulum, simple pendulum. So here I am going to solve this system is also called as a physical pendulum. Sometimes they may ask you what do you mean by that is a determine the natural frequency of the compound pendulum or physical pendulum. So here now I am going to reading this. That is a rigid body having an angular oscillation with a small amplitude under the action of the gravitational force, and it is suspended vertically, is called as compound pendulum. What do you mean by, what is the difference between simple pendulum and compound pendulum? Simple pendulum is only that is a swinging takes place and it is going to fix at the one particular position, and just if you give some force external it will vibrate. Whereas here what do you mean by compound pendulum? A rigid body. So normally it is a complete a rigid body having an angular oscillation, that is a angular oscillation takes place with a small amplitude under the action of the gravitational force, and it is normally fixed to the vertical direction. I will show you in the diagram. So this is about the compound pendulum. P and so here it is normally fixed in the rigid body, that is it is oscillation takes place in angular motion. So from at point P is a fixed point, and P to this G point is what the length going to consider as that is L, and the original position, that is the axis of the vertical point to the inclination, that angle is called as theta. At the point G we are going to get the three forces, that is a weight around, that is weight is equal to mg, and this side right hand side length is mg sin theta, and the another side is mg cos theta. So this is the and the length, the distance between the original position to this is what's equal to what, n into sin theta. So let the pendulum is a displaced that is a displaced through a small angle theta from the vertical mean equilibrium position. Just you going to disturb with an angle of theta. So we are going to get the jump, it will disturbance takes place. That is it will move from the original position to this point J, that is n sin theta. So let as the W is the weight of the body that is going to act the gravitation towards the gravitational force, that is weight is equal to mg, and k is equal to radius of the gyration of the body, and L is the distance of the point suspension from the point G, that is the distance between what point O to G. I is the moment of inertia of the body at point P, and I is equal to normally moment, that is the radius of gyration is equal to moment of inertia about the point P is equal to mk square plus ml square. So according to the same the Newton's second law, F is equal to ma. So F is equal to what here, I theta double dot is equal to sum of couple about the point P. So I theta double dot is equal to minus mg sin theta, distance that into length L. But we know that sin theta is equal to very small is equal to theta, therefore I theta dot is equal to minus mg theta L. So we know we have this I is equal to what, and that is mk square ml square. So m k square plus l square into the theta double dot is equal to minus mg theta L. So again we are going to divide this again just to reshuffle, that is rearrange this. Theta double dot m k square plus l square, so mg l theta is equal to 0. So divide this this what m k plus l square. We are going to get theta double dot plus mg l theta by m k square plus l square is equal to 0. So going to going to get cancel. So remaining is what, theta double dot plus gl divided by k square l square theta is equal to 0. Give question number 1. But we have we know that theta double dot plus omega n square theta is equal to 0. This is a normal definition already we derived in the previous slide. So now you compare the equation 1 and 2. So omega n square is equal to what, gl k divided by k square plus l square. So this is what omega n is equal to square root of gl divided by k square l square. So this is about the radian per second. We have to convert all the given particular system into this equation form, theta double dot omega n square theta. So if you convert this equation, so we are going to get easily omega n square. So this is about the angular frequency of the compound pendulum in radian per second. But they are asking what to determine the natural frequency. we have the natural frequency formula is equal to what? F of n is equal to 1 by 2 pi omega n. So already we calculate omega n is equal to square root of gl by k square plus l square. Okay, just to substitute that, f of n is equal to 1 by 2 pi square root of gl by k square plus l square is in hertz. Okay, so this is about the natural frequency of the compound pendulum. Okay, so here almost the formula look like similar, but the some the particular derivation how I'm going to solve, that is little different. Okay, so this is what the 1 by 2 pi square root of gl by k square plus l square. Okay, so sometime they may ask you some numerical problems, that is they sometimes they may give the value. Okay, then to based on the compound pendulum, then you are going to use these two formula, okay, to calculate angular frequency and natural frequency. Okay, now the third formula is that is the third problem is determine the natural frequency of the simple pendulum neglecting the mass of the rod. So in the previous case we solved what the considering the mass of the rod, but here we are going to neglect the mass of the rod, that is mr in between the that in between the rod, so that we are going to neglect that, we are going to calculate the natural frequency. Okay, so these three problems are very important for the point of examination. Okay, they may ask you some among three anyone. Okay, so this is about the simple pendulum. The figure A shows the simple pendulum. Figure C shows the what the forces generated from diagram, and last diagram you are going to see the free body diagram. Okay, so neglecting the mass of the rod, this is about the simple pendulum. This is a fixed point. So this is about the pendulum. So when if you disturb with if you disturb the simple pendulum with an angle of theta, it will oscillation takes place. Okay, and the length between the from fixed point to m, that is the mass of the bob, is considered as a L, and this the line is called as string. Okay, so once if you disturb, there is a forces, there are three forces will be acting on that. So that is weight is equal to mg, that is the gravitational force, and along the direction, that is mg sin theta, and okay, one more is mg cos theta. There is the formation of triangle will takes place. Okay, so that I do diagram I shown here this side. Okay, so neglecting the mass of the rod is equal to what? We are going to notation, we are going to consider the notation, that is m is equal to mass of the bob, l is the length of the rod, and I naught is equal to moment of inertia about the O, and I naught is given as m into l square. Okay, m, that is mass into distance square, ml square. Okay, so by according to the Newton's second law, that is same, F is equal to ma, sum of forces is equal to, that is the acceleration torque is equal to restoring torque, that is okay, F is equal to ma. So here I naught theta double dot is equal to minus mg sin theta into l. This is the distance into length, but sin theta is equal to theta, so remaining is what? So I naught theta dot is equal to minus mg theta l. Okay, so I naught is equal to what? Ml square theta as it is plus mgl theta is equal to 0. So divide this ml square, you are going to what theta double dot plus g by l theta is equal to 0. So mm going to get cancelled. Okay, so it is a equation of motion, but we have what? Theta double dot plus omega n, this is equal to omega n square into theta is equal to 0. So equation number 2. So mass of the rod rotated about the fixed point. So this is I shown in the free body diagram also. This is the rotation. Okay, so next compare equation 1 and 2, we are going to get omega n is equal to square root of g by l. So here just to take this g by l, this formula. Okay, so now the natural frequency f of n is equal to what? 1 by 2 pi omega n. So substitute omega n value here. So here f of n is equal to 1 by 2 pi square root of g by l. So this is about the natural frequency of what the simple pendulum when neglecting the mass of the rod. So this another method is also there. Okay, so this is another method to find how we are going to determine the another method. Okay, so here same, so here I is equal to what? Mg cos theta, that is take considering the another method. Okay, restoring force f of x, f is equal to what? Mg sin theta. So but sin theta is equal to very small, that is equal to theta, f is equal to mg theta. Okay, so here one more moment is equal to what? That is force is equal to m into ma, that is the Newton's second law. Okay, so compare equation 1 and 2, ma is equal to minus mg theta. So here mm we are going to get cancelled, a is equal to minus g theta, minus g into theta, give equation number 3. So theta is nothing but what? The distance about the point O divided by L. Okay, that is arc of AB is equal to L. So arc AB is equal to from the diagram, that is x by L. Okay, so displacement is equal to what? X by L. So A is equal to minus G. So just to substitute there, theta x by L, that is equal to constant. Okay, A is directly proportional, that is A is directly proportional to minus x, that is A is equal to what? Minus g by L into x, give equation number 4. Okay, A is equal to minus, this is what? The angular frequency minus g by L omega square into x, give equation number 5. So compare equation again, the 4 and 5, that negative sign going to get cancelled. So remaining is what? Omega square into g by L. So now we are going to get omega n is equal to square root of g by L. So we have the natural frequency formula is equal to what? F of n is equal to omega n by 2 pi. Okay, therefore 1 by 2 pi just to substitute the omega n value, you are going to get the natural frequency of the simple pendulum when neglecting the mass of the rod. Okay, so this is about the natural frequency of the compound pendulum and the simple pendulum. Okay, so here in examination they may ask you considering the neglecting the mass of the rod and considering the mass of the rod of a simple pendulum. That is very important. So read question carefully and solve here. So here nothing value will be given, so no data, no given data, nothing. Just you have to analyze the given question, that is a given formula, then you have to solve. Okay, so all problems belongs to Newton's second law, that is F is equal to ma. Okay, in terms of that is a torque equation, or normally in the types of force. Okay, so this is about the diagram of compound pendulum. Okay, so compound pendulum is going to, we are going to consider the rigid body. Okay, so this is about what, so here compound pendulum definition also are out here. A rigid body having an angular oscillation, that is a rigid body, a rigid fixed body having an the rotation, that is oscillation with a small amplitude under the action of the gravitational force, and it is suspended vertically, not horizontally. Okay, is called as compound pendulum. Okay, so this is about the what the natural frequency of problems, how we are going to solve. So here we are going to use the Newton's second law for that is okay, that is very important. Okay, so I hope you understand these two problems. Thank you.